Hey there, energy enthusiasts! Let's talk about something super cool, energy management systems, or EMS for short. Imagine a smart brain controlling our power grid, making sure everything runs smoothly. That's EMS in a nutshell. In a world rapidly shifting towards renewable energy, EMS is becoming increasingly important. EMS is a software platform that helps us manage and optimize how we use energy. With the rise of renewable energy sources like solar and wind, our power grid is becoming more complex. That's where EMS comes in, helping us integrate these clean energy sources seamlessly. Think of it like this. Our power grid is like a highway, and electricity is like the cars traveling on it. EMS is like the traffic management system, making sure the traffic flows smoothly and efficiently. By managing our energy consumption and integrating renewable energy sources, EMS is helping us create a cleaner, greener tomorrow. Now, let's dive deeper into the world of EMS and explore its key components and functions. Okay, so we know EMS is the brain of the operation, but what are the key parts of this smart system? Think of EMS as a team of specialists working together to manage our energy. First up, we have the grid controller, the traffic cop of our power grid. It's responsible for keeping the grid stable and making sure the electricity flows where it's needed most. Next, we have the battery energy storage system, or BESS for short. Think of BESS as a giant battery that can store excess energy for later use. It's like having a backup power source that can kick in when demand is high or if there's an outage. Now, every team needs a boss, right? That's where the control center comes in. It's the central command center that monitors everything happening on the grid. The control center collects data from sensors and meters, analyzes it, and then sends instructions to the grid controller and BESS to optimize energy usage. Now, let's move on to the functions of EMS and how it works with BESS to make our power grid smarter and more efficient. Alright, we've met the team. Now let's see them in action. EMS, with the help of BESS, performs key functions to keep our power grid smooth. Load management balances supply and demand. BESS stores excess energy and discharges it during spikes. This prevents blackouts and ensures reliability. Grid stabilization maintains frequency and voltage. EMS uses BESS to smooth out sudden changes. It's crucial with renewable energy sources. EMS optimizes energy costs by managing BESS. It charges when prices are low and discharges during peak hours. EMS integrates renewables by storing excess energy. Finally, EMS promotes demand response. Consumers adjust usage based on grid conditions. Let's talk strategy. EMS employs several clever strategies to optimize the use of BESS and ensure a reliable and efficient power grid. Imagine you have a battery-powered flashlight. You wouldn't want to use it all at once, would you? You'd want to conserve its energy for when you need it most. That's the idea behind peak shaving, one of the key operational strategies of EMS. During periods of high electricity demand, like hot summer afternoons, EMS can instruct BESS to discharge stored energy, reducing the strain on the grid and preventing blackouts. Another strategy is load leveling. Electricity demand fluctuates throughout the day. Load leveling aims to distribute energy consumption more evenly, reducing stress on the grid and making it more efficient. Arbitrage is a strategy where EMS takes advantage of fluctuating electricity prices. BESS charges up when prices are low, like during the night, and discharges when prices are high, selling that energy back to the grid for a profit. Finally, we have black start capability, a crucial strategy for grid resilience. BESS, with its stored energy, can act as a jumpstart for the grid, providing the initial power needed to bring other generators back online. Section 5. Control techniques for BESS and EMS. Now let's get a little more technical and explore the control techniques EMS uses to manage BESS. First up, we have state of charge, or SOC control. This technique is all about keeping the BESS within a safe operating range, kind of like making sure your phone's battery doesn't completely drain or overcharge. EMS monitors the BESS's SOC and adjusts charging and discharging accordingly to prevent damage and prolong its lifespan. Next, we have model predictive control, or MPC, a more advanced technique that's like having a crystal ball for the power grid. MPC uses sophisticated algorithms to predict future energy demand and grid conditions. Based on these predictions, EMS can proactively adjust BESS operation to optimize performance and ensure grid stability. For simpler applications, EMS can use rule-based control. This involves setting predefined rules for BESS operation based on specific grid parameters. These control techniques work together to ensure that BESS is always operating at its best, maximizing its potential and contributing to a more reliable and efficient power grid. Section 6. Benefits of EMS with BESS integration. By now you're probably thinking, wow, EMS with BESS sounds pretty amazing, and you're right. Integrating these two technologies brings a whole host of benefits to the table. First and foremost, it significantly increased grid reliability. EMS with BESS helps prevent blackouts by providing backup power and stabilizing the grid. Another major benefit is enhanced renewable utilization. EMS with BESS solves the problem of intermittent solar and wind power by storing excess renewable energy for later use. Of course, we can't forget about the cost savings. EMS with BESS helps reduce our electricity bills in several ways, by optimizing energy usage, reducing peak demand, and even participating in energy markets. EMS with BESS puts more money back in our pockets. Last but certainly not least, EMS with BESS has a positive environmental impact. By maximizing the use of renewable energy and reducing our reliance on fossil fuels, this dynamic duo is helping us combat climate change and create a cleaner, healthier planet. It's a win-win for our wallets and the environment. Section 7. Applications in real-world scenarios. Now that we've covered the benefits, let's take a look at how EMS with BESS is being used in the real world. From small communities to bustling cities, this technology is making a big impact across the globe. Imagine a remote island community, far from the mainland grid. How do they get reliable power? Microgrids. These small-scale grids use solar panels, wind turbines, and BESS to generate and store their own energy. EMS acts as the conductor, orchestrating the entire operation and ensuring a stable and sustainable power supply for the island. Moving to the urban jungle, we have smart cities, where technology is used to improve efficiency and quality of life. EMS with BESS plays a crucial role in managing the complex energy needs of a city. From optimizing traffic flow to reducing pollution, EMS with BESS helps create a more sustainable and livable urban environment. Finally, let's talk about utility-scale projects where things get really big. EMS with BESS is essential for integrating large-scale renewable energy projects into the grid, ensuring stability and reliability. Section 8. Evolution and modernization of EMS. Remember when mobile phones were big and clunky? Just like technology has evolved, so has EMS. Modern EMS solutions are all about adaptability and flexibility. They're designed to work with various battery systems and can be easily integrated into existing grids. Cloud computing has also revolutionized the EMS world. Cloud-based EMS platforms can handle massive amounts of data from the grid and BESS, enabling more sophisticated control and optimization. But it's not just about the cloud. Edge computing is also playing an increasingly important role in EMS. By processing data closer to the source, such as at the BESS site, edge computing reduces latency and improves response times. Modern EMS solutions are also designed with cybersecurity in mind. With the increasing threat of cyber attacks, it's crucial to have robust security measures in place to protect our critical energy infrastructure. Section 9. Future outlook and importance of EMS for BESS. As we look towards the future, one thing is clear. EMS for BESS is not just a nice-to-have, it's a must-have. As the world transitions towards a cleaner and more sustainable energy future, the role of EMS will only become more critical. The increasing penetration of electric vehicles, or EVs, presents both a challenge and an opportunity for the grid. EMS with BESS can help mitigate the impact of EV charging on the grid by shifting charging to off-peak hours and using EVs as a distributed energy storage resource. The future of EMS is bright, with advancements in artificial intelligence and machine learning paving the way for even smarter and more efficient energy management. Imagine an EMS system that can predict grid instability before it even happens, or optimize energy usage based on weather patterns and consumer behavior. In conclusion, EMS for BESS is an essential tool for modernizing our power grid and building a more sustainable energy future. By investing in these technologies, we're not just keeping the lights on, we're creating a cleaner, more efficient, and more resilient energy system for generations to come. So let's embrace the power of EMS and BESS and build a brighter energy future together. Thank you for joining us on this electrifying journey.